I wanted to talk to you guys again about my Graviflyer. I had a couple of questions that came in and I just wanted to answer them. One of the questions that I got was this: how come the center plate and the outside bars are all electrically connected? Basically just meaning they're connected together without anything stopping the electricity from flowing from one to the other. Well, there's a reason for that. You're trying to build an outside field and an inside field. You want the inside to suck in. So when you see the top plate here and the bottom plate under it, it actually forces them together. Everything pushes in. From small plate to big plate, it pushes in. And it makes a gravity effect. It pulls it in. If you saw the experiment that I did on the aluminum foil, just on the piece of wood, how it sucks down in there, that's exactly what you're looking for here. You're looking for that sucking down feature of making it like you're basically trying to make a gravity well. You're trying to suck in all the power. And then you want to feel it on the outside. So this on the outside here has to be different. It has to push out. And that's what he's trying to achieve here in his Graviflyer. Now, there's a problem with it. Just so we all know here, he used a toroidal effect. So basically, if you took this here, this right here, Tesla coil, and I take this top piece, and the top piece is this right here, what am I missing? Well, this right here is what I want. I want this. I don't want this. This is not going to do anybody any good. You want this, and you want another one like this. You're trying to make a north and a south pole on it. That's where this kind of falls short. You can't use this piece here to create this here field. It doesn't work. The field comes from this coil here pushing it out. So that's kind of what that has to be on there for. That's the field. What it's trying to do is push the electrons out so that you can create a tunnel for this thing to go in. You have to separate it from what we're feeling in gravity. That's the reason why you put an inside and an outside field. So I had another question. If I decide to put the Tesla coil in the center, do I need the disc anymore? Well, the answer is no. Here's why. When you put the wire on it and you spin the disc, frequency is F equals 1 over T, which is a very simple equation. Frequency equals 1 over time. That just basically means every time a certain point of this disc spins around and gets back to that same point, the amount of time it has is a frequency. It's simple, not a real hard thing to figure out. So if I add a Tesla coil, it'll add frequency for me. I do not need to have the frequency anymore. Now, I know a lot of you out there have watched this test and you're wondering what's going on here. Well, let me explain it. You can see that I'm turning up and down the dials here. I'm just basically running this out of balance. Completely out of balance. It will not look right when the discs are running like this. So, you see it shaking? The question is that lift? And the answer is no. What's going on here? Here's the magnets right here on this disc. No magnets on this disc. We're getting an imbalanced motor. If you ever had a bad motor and it wobbles like this on a fan or something, that's what's going on here. There's no lift in this. This was simply a test to see that the top and bottom disc, what speed do I want to run them at? And which one's better? Now, I could put legs on this and stuff like that, but it's ultimately unnecessary. You can, if you want to make the most pristine looking Graviflyer ever. It'll do great sitting on your desk. It'll spin, it'll look beautiful. But I'm not into that. I want to test it. I want to run things out of balance. I want to run things with higher frequency. I want to run the voltage right through the roof if I can. So, let's take a look. So it's in balance, and you'll see it wobble. The frame itself flexes like this. So it creates that wobble effect inside there. It's moving up and down on there. Why? Because it's aluminum. You can bend it with your hands. It's not steel or anything that's rigid. It's aluminum. So it bends a little bit. So you're getting a wobble like that. So let's take a look a little more. It looks like it's going to fly right off the ground. I mean, I see it. I wish it did. Trust me, if I could just throw a massive amount of voltage in this and lift it, I would. It'd be the greatest thing ever. It's just not possible. You can see they're a little more in tune with each other. Probably not. But a little better, a little better. You kind of got to get a feel for where you're going with it. Let's see if I can capture the side over here. I'm looking for something. Right here, that's actually a piece of copper. It comes down, sits on the plate, runs a little better than putting just a straight wire on it. You'll see I used a cable in here. I do not use a high voltage cable. I used a coax cable. There's a reason for that. When you go to look at how to insulate a cable, it'll tell you here's your cable, put shielding over it, then put wire shielding over it. You can use aluminum tape as a shielding as well, and then it tells you to cover it again. Exactly what a coax cable is. So what you'll notice if you ever play with high voltage, if you try to touch the wire, if a cable is too thin, you're going to get zapped. But if you put it in a coax cable, you won't. There's too much insulation there. So I prefer to use the coax cable because it brings the voltage over without lowering it. So you can buy some expensive cables out there if you like. I prefer to do it this way. This is a simple solution and it's cheap. And most people just throw this stuff away because we don't use a whole lot of it anymore. So it's free. So go for it. It's a lot better. So I got some questions on this and I just want to answer them for you. This right here was simply a voltage test. Now, all these bolts you see right here that go into this are metal. And I made the mistake of not changing them to plastic or nylon. And what happens is right here, the bolts on everything start to arc over. The voltage goes in, they start to arc over. So if you're wondering what this test was, this is basically what it is. It's arcing over. So you'll see it here right in the middle. Right about right now it starts. You see it? All that arcing in there? I'll try to show you a better look. But you can see just a little bit. Everything's arcing over because I didn't separate it properly. These discs have to be separated from this metal out here. And just remember how long your spark gap is when you test your flyback transformer. It's probably about this long. So the distance there has to be longer so it doesn't arc over when you put in from your metal to metal. So hopefully that makes sense to you. So what was I looking at in this test here? Let's take a look. I made the center plate negative. That means on both sides you're getting this feature here on the top and bottom plate. Why is this important? Why was I looking to show you this and amplify the effect? Well, it pushes down, pushes things together in the center, creates a gravity effect. That's basically what it's doing. That's what I wanted to show here in this. Now it's a beautiful sight. Trust me, I like looking at it. And I've recreated it in many ways. You can do it with a drill and a flat piece of aluminum. But this right here is what I was looking for. I wanted it to go down, so I wanted it to push in, just like that aluminum foil. This test here was something that I did. I wanted to put high voltage on both sides. Maybe I was missing something. So let's go ahead and push it a little further and let's take a look. As you can see, hot wire, negative wire, both to the same disc. I did the same on the bottom here. And it didn't really create any better effect on anything, but it was something that I did to test it and take a look at it and just see what happens when things, go a little differently than they're designed to do, and it really didn't do anything. I wanted to show you this right here in my Graviflyer experiments. I explain frequency so that you guys understand it out there. This right here, 58.27, is the frequency of aluminum. So that's why you see it in there and why I wrote it in there. Now, every time you double this, like here it says 116.54, you double the frequency, it's still the same frequency. It's just later in the line of the progressive run as your frequency flows. So, what does that mean? It basically means that you can reduce it down to a small number. If you want to run a number in, like, say, the 2 or 4 in the beginning, or single digit in the beginning, you can multiply it out. As long as this number here divides down to it, you're good to go. And you have to divide it by 2 every time, or go forward, multiply it by 2, and you'll get there. Why is this important? Tesla said when you go ahead and start something at a low frequency to a high frequency, it makes it easier to hit that high frequency because you're not missing anything. He used that in his earthquake experiment. You'll probably see that the number was really fairly low, and then it got to something higher. Why? Because he didn't want to miss anything in between. He wanted to hit every single time the wave pattern goes up and down. This is frequency. It's pretty easy to understand once you see that, but it's easier just to build like a Tesla coil and set it to the correct amount of turns to get the frequency. But if you don't know this, it's kind of hard to hit the thing if you're trying to reduce the Tesla coil something like this small. I did this experiment here. It's basically a bifilar coil. Now I used DC when I did it. That's why you see the magnets have an effect on it. I should have used AC in this. Now, it's quite big, oversized for the Graviflyer, just adds a ton of weight. But I'm trying to understand relationships here when you build something. So here's the disc here. You'll see I'll put magnets on it, and the magnets react because it's DC. So you'll see them jumping there. They jump in my hand a little bit, even at that length right there. It's hard to see it. It's easy to feel it, it's hard to see it. And here we go, I think I got it here. You see it jumping a little bit right there. Basically what I'm trying to show is there's a field emanating from it. When you get into the AC, it emanates differently. Right here, it has that effect on the magnets. With the AC, it's producing a magnetic field without that effect on the magnets. That's why that coil is important. Now I do some fog testing on stuff because I want to see where airflow goes. If it has anything to do with the fields or airflow, I try to generally test everything in every way that I can. So this is a video I was just trying to test the airflow. You'll see it come around here as the discs are spinning. There's no center plate in this one, but I just wanted to show the flow of air. That's what I was trying to look for here. As you can see, it comes around here and blows out here, but that's basically it. All the lights on this are on my fog machine. It's not there, but it does make a cool look. Just to show you a quick test here, I ran it without the center plate with 2 discs, and I basically put voltage in both, and I was just trying to see what it does. So when you spin magnets and it goes to aluminum, you get an eddy current. So in this video right here, I'm trying to show the eddy current in the Graviflyer. Again, the center disc is removed. Now I don't have any power on this one on the bottom here, just so you know. As the top disc spins, the bottom magnets want to force themselves away from it. So you can see them pushing away and moving on this. You see, I stopped it, and there you can see it starting up again. It's just going to keep going until it gets faster. You see the magnets have an effect on my screwdriver. So, just some strange phenomena that happen. Just so you understand, there's a little bit of eddy current there. It flows, it looks cool. nice to look at. Doesn't help us in the Graviflyer whatsoever. Okay, I just wanted to show you this right here. This is the whole bottom half of my Graviflyer missing. I only put from the center plate up. And here's why. Everybody says, well, did you measure this on a scale? Did you see if it has a lighter amount? Well, I'm going to tell you right now, putting anything like a Graviflyer on a scale is a bad idea. It is a false positive. It does not get you the correct effect. And why? Because anytime you take an imbalance like those magnets, it'll create what looks like a lighter effect because it's dancing. It's not going to do it. You can have it as flat as it could be. It will not show you the correct answer. This right here shows you a little better. It shows you when you take the top plate to the center plate here and you put the voltage on it, it creates force. It's not lift, it's force. It's forcing that plate down. What you don't know is this right here, this bolt, it went right into my piece of wood right here. That's why you see the wood on top of the tabletop here. It actually went 1/4 inch down in less than 30 seconds. It dug a hole. Why? Because there's so much force on it pushing down. That's the gravity effect I was talking about. That's why this test was important. So you can see it here. This won't move. This whole thing shakes. This won't move. It's stuck. It's already dug itself in. There is a lot of force being pushed down on this. You see, it wants to jump up. It's stuck in the hole. You know, I get this question all the time, does this Graviflyer work? And the simple answer is no. I've never seen one that works in my life. I've seen some from the original creator, but if you can't replicate it, you cannot say that something works. In every test that I've done, I've never gotten this thing to lift even 1 inch off the table. So I always say this to people, great idea. It's like reading a book and going to build this thing. All the concepts are there. You have a lot of it understood that you think you know, but until you do the individual testing on it, you don't know. You don't understand why things are working the way they are. It's very important to understand that. Without that, you build something that doesn't work. And then you can test the equations on it, and the equations are just right on. But it's still wrong. Why? Because you didn't do the scientific test to get there. I always show the test. Sometimes it's raw footage, sometimes it's, you know, I go over it and I talk about it, but I always try to show it. And I always tell you the straight answer. Because I hate when I get onto something and I can't figure it out, and then somebody just says, oh, it works, go for it. And no, that doesn't work for me. Show me the details. And that's what I try to do in these videos. I'm showing you the details. Now this is one of the last times I'll probably show you, so I may do it one more time in a giant retrospective. One of the last times I show the version in this. It's time to get on to something that we know that's going to work right. This right here, simple lifter. Doesn't look like a regular lifter. Why is there not a big hole in the middle? Well, it doesn't work on the same principle. It works on going through sound. Here's the wire up here. Here's a plate down here. It's about 6 inches of difference. Right now, this thing lifts. It'll be in one of my next videos that I do to show it lifts. But it takes one heck of a lot of voltage to do it. But the cool thing is we get this. We get this plate right here, solid. That's the important feature of it. So in the next Graviflyer, all this is going to change. We're going to start very small, and we're going to grow to something bigger. And I'm going to show you step by step how we make something fly in the air that has solid sides. That's going to be the trick. Now this one's already lifted. I'll have that video out probably in the next few months. I blew out some capacitors and I'm waiting for those to come in so that I can redo the experiment. But it's really cool. Anyway, that's where we're going from here. I just wanted to answer that last question, and I really hope you guys enjoyed the video today. If you like what you saw here today, please like and subscribe. Thank you. For those of you who watched to the very end, I just want to leave a little bonus footage for you here. Here's a gentleman who built one of these as well. It lifts, it comes right up off the ground. And if you take a look at this lightning bolt later on in the video, you'll see exactly how far up he is, about 8-9 inches up there in the air with the second wire. There's no chance for any kind of significant ion flow here. And I'll prove that in the testing that I do next. But anyway, I didn't want to leave you without showing you one of these lifting. And hopefully you enjoy the video. Thanks. Here's the guy that created this lifter here. I just want to give you his information so you can look him up online. I'll leave a link in the description. Thanks again.